question 3, we're going to simplify by using absolute values. So here we're looking at fourth root, so I could rewrite this as 81 to the 1/4 and x to the 4/4, so that reduces nicely. 81 to the 1/4 is 3, and x to the 4/4, that would be x to the first. Okay. Now, because x could be negative, when we would plug it back in, right? When we plug it back in here, anything to the fourth, a negative to the fourth is always just going to be positive, right? So since there's a possibility of that being negative to begin with, we're going to put that in absolute value bars. Okay, and then here on this next one, the 256, that's going to be raised because this multiplication here, that's going to be raised to the 1/8. And then our second part of the radicand is y squared minus 2, and that's being raised to the 24th. So that would be numerator be 24, and the index, the denominator, would be 8, which reduces nicely. 256 to the 1/8 is 2, and then this would reduce nicely to 3. Now again, because this is an even amount, if I put a negative in here, right, this is automatically for y, it's automatically going to become positive. So I need to surround that in absolute value bars as well, right? So then if I plug a negative in there, eventually it's just going to be positive because of those absolute value bars. And so why that's important is because just in case I have a negative in there, when I take the principal square root of this, when I only look at the positive answers, right, I need to make sure that my index, or not my index, sorry, my radicand in there has to be positive. So when I take it, I get a positive out. So anytime you have a square root, fourth root, and eighth root, and you need to make sure that if you have a negative in there, that you can still take that. So that's why you put those absolute value bars there.